Alright, grade 11s and grade 12s, this section is under acids and base. Let's look at the mixtures. Look at the mixtures of strong acid and strong base, as well as the pH. So now the mixing of an acid and base delivers a solution where solution can be either an acid or base or neutral, depending on the relative reactants present. The following two methods can be used as guideline to calculate the pH of the reaction between an acid and a base. So I normally use method 1. So we are going to use this method. The other method, you can just copy and see if maybe it will work for you. So this method, the first step there, you calculate the number of mole acid and the number of mole base in the solution. So that will be the first step. We are going to look at the example. This example is example 18. I'm having 25 centimeter cubed, which is the volume, and the concentration of 0.1 mole per decimeter cubed of sulfuric acid solution is added. Now this one is added. Remember, if you hear the word added, you are not going to use that formula like I indicated earlier. CAVA, CBVB, number of moles of acid, number of moles for base. This one is out. Is added. We are not going to use this one, but we will rather concentration, number of moles, and also this one. So this one is going to be the formula that will be used throughout the calculations, not that one. So this method should be general guideline to calculate the pH. Okay. Calculate the number of moles of acid or base that is neutralized. So now here, that the one which is neutralized should be same as the one which is reacted. So this stage, before we can get there, I'll show you something there. Okay. Calculate the mole acid or base that remain in excess. So this one will remain, which is in excess or unreacted. So this is where we're going to use unreacted will be equal to initial number of moles minus the reacted number of moles, or it should be neutralized if you want to use that weight. Okay, so meaning initially it will be from the first step there, so to calculate the number of moles. So then we have step 4, calculate the concentration of the acid or the base that remained, because now the mixing of acid and a base, this step we're going to add the volume. So it will be volume for acid together volume for the base. So that will be the total volume. Okay, then now we calculate the pH of the solution. So this is the final stage. We are going to calculate the pH of the solution. So let us look at this question. I'm having 25 centimeter cubed of a 0.1 mole per decimeter cubed of sulfuric acid solution is added to a 30 centimeter cubed of 0.1 mole per decimeter cubed solution of sodium hydroxide calculate the pH of the final solution. Okay, by using method 1. Method 1, what we have here, they just collected the data. Then we have, this is the reaction of is H2SO4. Then now, together with sodium hydroxide. So what we get? We get sodium sulfate, and then there's water as the product. But what is important here, I've just copied from step 2 there, the balance equation. I wanted to show you something there. So now we can see that from that information above, there is 25 centimeter cubed, there is 0.1 of H2SO4. So now I'm having 25. The volume, you convert it to decimeter cubed. That was converted. 0.1 is still there. So we need to calculate what? The number of moles. So this one we have 30 centimeter cubed. So we convert it 0.03 decimeter cubed. The concentration is still there. We need to calculate the number of moles. So our first step there. First step, calculate the number of moles of acid, and this is not or, is and. So we are calculating both number of moles for acid as well as the number of moles for the base. So that was the first step. So we calculated both number of moles of acid and the number of moles. So the step number two, calculate the number of moles of acid or a base. Now this is a big statement here. This is or a base that is neutralized, which is the reactant. How do you know that? Which one you're going to choose between acids and a base? So we are going to check between the two, which one is a limiting reactant. So now, because I'm having the ratio, my ratio is 1 is to 2 there. So sodium hydroxide ratio is 2. I'm going to divide it by 2 there. So if you divide by 2, you're going to get 0.0015 mole. So this one, you're going to divide it by 1, which is the ratio. So now you're going to get 0.0025 mole. So then you compare the two answers. So this one, it should be a limiting the reactant. So this one is the limiting reactant. This one is in excess. So now if you look at this step 2, we need to calculate the one which is reacted. We are going to use the ratio. So I know step number 2. Now the one which is neutralized, you calculate the number of moles of sulfuric acid. Why sulfuric acid, not sodium hydroxide? I'm going to work with the one which is in excess. To move on, I'm not going to work with the one which is limited, but I'm going to work with the one which is in excess. This is how you know whether you're going to work with the sulfuric acid or you're going to work with sodium hydroxide. You need to identify the one which is in excess, the one which is a limiting reactants. So I know the sulfuric acid because 0.025 is more than 0.015. So now the reacted one, I need to use the ratio. So the step number 2 there, now I'm using the ratio. The ratio, it must be 1:2. So now what I want the number of moles for what? I want the number of moles for the acid reacted. It will be X. But the number of moles for what? I'm going to use the number of moles for sodium hydroxide. The number of moles for sodium hydroxide, which is limited 0,003. Then now you'll be working with X. These are the number of moles that will be neutralized or can be reacted. So these are the number of moles of an acid which reacted in the reaction. So initially, I'm having at the top there, step number 3, calculate the number of moles of acid or a base. So I know this part of the base, I'll work with the acid because this one is limited. So that is in excess. So step number 3, the one which is in excess, I'm going to say, which is unreacted or can be unreacted or can be an excess or can be remained. So it will be the initial number of moles from the step number 1. So I know the number of moles initially for sulfuric acid is 0,0025 minus the one that I used in step 2, which is by using the ratio, the number of moles which is neutralized is the same as the one which is reacted. So this is the number of moles which is reacted. Then now this will be the one that is in excess. So if I'm having the number of moles in excess, I can say the concentration, which is the step 4, before my last step, step number 4, calculate the concentration of the acid, remained, okay? Then now the final, calculate the pH, the concentration, it will be the number of moles over the volume. So now we need to be careful to this step, the total volume. So we're going to add the total volume, or 0,025. Where is the volume? 0,025 and 0,03 and 0,03. So this step, concentration number of moles over the volume. So we know this step is a crucial step. So I'm going to I need to get V total. The number of moles that will be in excess, we substitute this number of moles there. So the total volume, which is this one, we substitute there, we get the concentration. So the pH is negative logarithm of H3O plus. So we check it here. Now because it's sulfuric acid, so this one is diprotic acid. So it can donate how many protons? It can donate 2 protons. So that will be, it can donate 2 protons. Then now we know the concentration is 0,018. Then we get the final answer like they did it here. So you get 1,44. So this is the pH, the final solution. Thank you very much. So we can just go up, then we start it there. There's also method 2 there. If you're interested in method 2, then just show you, this is a video. I'll show you method 2. Let me go down and down and down. That will be 1,44. You can also try it by using method 2. Thank you very much.